Welcome to my channel. Today we are going to discuss about the MCQ questions from the part Laplace transform. So in the previous 6 videos we discussed the first 4 videos is for first unit, then the fifth part is for Fourier series, and part 6 is for Fourier transform. So now we are going to discuss about the questions from the Laplace transform. So you know general about the Laplace transform. So the Laplace transform is exist for maximum signals. Okay, the Fourier transform exists only for the non-periodic signal of finite energy, but the Laplace transform is applicable for all the signals. Okay, in Fourier transform, so we will not calculated the Fourier transform for ramp signal, rising exponent, etc. Okay, Fourier transform is not existing, but in Laplace transform for all signal we can calculate the Laplace transform answer. Okay, so that is the advantages of the Laplace transform. So already we discussed these things. Okay, so now we will see the question and answers. Okay, so the first question, you see, the necessary condition for convergence of Laplace transform is the absolute integrability of f of t into e power minus sigma t. It's a true or false. It's a true only. Okay, so in order to satisfy that is for one signal, if we want to take the Laplace transform, means it must satisfy the condition is that signal, okay, that signal, it is absolutely integrable. That is the product of the signal into e power minus st or sigma t dt, it should be less than infinity. Okay, so the statement is correct. The convergence of Laplace transform is absolute integrability. Okay, this is the necessary condition. Yes, it's a true only. And find the Laplace transform of del of t. So you know, for any transform, if you are taking any transform for impulse signal, the answer is 1. So the Fourier transform answer for the impulse signal is also 1. The Laplace transform answer is also 1. Okay, so these are the standard signal. You should remember that. Okay, so if you want to how to get this answer 1 means, so I will give a link in the description box for that video. You go and search. Okay, so already we solved how to find the Laplace transform of del of t problem, u of t, and all standard signals we solved separately. Okay, so I will give link for those videos in the description box. You can verify it. So the Laplace transform of del of t, the answer is 1. Okay, you have to remember it. And find the Laplace transform of e power minus at u of t and its ROC. Okay, so you know already we solved this problem. Okay, so the Laplace transform of e power minus at is 1 divided by s plus a. Okay, so here there are 4 choices there. One is 1 by s minus a, it is wrong. 1 by s, it is wrong. 1 by s plus a, 1 by s plus a. So 2 times 1 by s plus a is given. But the ROC, you see, the ROC is, the first thing is real of s. That is real of s means sigma. Sigma greater than a. Okay, in the third choice. In the fourth choice, sigma greater than minus a. So which one is correct means, so here you see e power minus at u of t. So e power minus at u of t, the Laplace transform is 1 divided by s plus a. Okay, so in this s plus a, so which one is a pole? Pole is a minus a. Okay, so minus a. So that's why, and this signal is a causal signal. So you know, for causal signal, the ROC is the real of s, it should be greater than that pole value. So that's why the sigma real of s greater than minus a. This is the answer. Okay, so for causal signal, always the ROC is a that is greater than some value. So here the pole value is minus a. Okay, so that's why 1 divided by s plus a is the Laplace transform answer, and the real of s, it is greater than minus a. Okay, so this problem already we solved as a separate video. Okay, so using the Laplace transform formula, what is the Laplace transform formula? Integration minus infinity to infinity x of t e power minus st into dt. So using this formula, so already we solved these problems as a separately. So you see, this is the del of t problem. Okay, Laplace transform of del of t, the answer is 1. Okay, the ROC is entire S plane. Okay, this is also a one of the questions. So what is the ROC for the unit impulse signal means? The ROC is the entire plane. Okay, this is also a one of the MCQ question. And find the Laplace transform of unit step signal. So the Laplace transform of unit step signal is, the answer is 1 divided by s. And the ROC is sigma greater than 0. That is the real of s greater than 0 is the ROC. Okay. R of t. Okay, so these questions are coming in the next thing. So similarly, e power minus at u of t problem. So just now we see the e power minus at u of t problem. The answer is 1 by s plus a. And you see what is the ROC? The real of s, that is sigma, it should be greater than minus a. So this portion, okay, the portion above the pole minus a, it is called as a ROC. Okay, so all problems we solved already. That all things, it is available in a signals and system playlist in my channel. So I will give the link in the description box. You can verify it. And find the Laplace transform of u of t and its ROC. So already you know what is the Laplace transform of the unit step signal u of t. So you see the Laplace transform of unit step signal is 1 divided by s. Okay, these are all the very standard answers. Okay, so unit step signal, that is the Laplace transform is 1 divided by s, and the ROC is sigma greater than 0. So 1 by s with a sigma less than 0, 1 by s with a sigma greater than 0, 1 by s minus 1 sigma equal to 0, 1 by 1 minus s sigma less than or equal to 0. So the answer is 1 divided by s when sigma greater than 0. This is the Laplace transform of u of t. Okay, and find the ROC of the signal e power minus 2t u of t plus e power minus 3t u of t. So here the question is only we have to find the ROC. So here the signal x of t consisting of the addition of two signal, okay, two exponential signal. So first we have to calculate the Laplace transform. So you see the explanation. This is the given signal x of t. So if you are taking Laplace transform for the first signal e power minus 2t u of t means already you know, as per the previous problem, e power minus 8t u of t means the answer is 1 by s plus a with the real of s greater than minus a. So here e power minus 2t u of t means, so the answer is 1 divided by s plus 2. Okay. Similarly, plus what is the Laplace transform of the second signal e power minus 3t? 1 divided by s plus 3. Okay. So what is the ROC for the first e power minus 2t u of t signal? So the sigma, it should be greater than minus 2. Okay. So what is the ROC for the second part? The sigma greater than minus 3. So if the given signal consisting of two signal means, so the combined ROC is the intersection of these two ROC. So one ROC is sigma greater than minus 2, another ROC is sigma greater than minus 3. So which portion is said to be the intersection of these two things? So one is, you see, this one you just consider minus 2. Okay. So the first ROC is that the portion above minus 2, this is the ROC 1. Then the second ROC 2 is sigma greater than minus 3. So where is the minus 3? This is minus 2 means here it's a minus 3. So the portion that is above this minus 3, it is the this one. So these two ROCs where that is overlap. So sigma greater than minus 2 region only, the ROC1 and ROC2 is overlapped. So that's why the combined ROC is sigma greater than minus 2. So that's why the answer is sigma greater than minus 2 is the ROC for this combined signal. Okay. So ROC is the intersection of the first ROC and second ROC. So the intersection where we are appearing means sigma greater than minus 2. Okay. Then the next question, find the Laplace transform of cos omega t u of t. Okay. So these problems are already, that is in Fourier transform also we discussed these problems. Okay. So what is the relation between Fourier and Laplace transform means? In the j omega, in the place of j omega, if you are substituting s means that is the Laplace transform answer. Okay. So the Laplace transform of cos omega t u of t. So the answer is s divided by s squared plus omega squared. Okay, this is the answer. If it is a Fourier transform means you just replace s by j omega. So j omega by j omega the whole square plus omega squared. It is a Fourier transform. Okay. So this cos omega t and sin omega t problem already we solved in that previous that in the videos. Okay, you see this is the a sin omega t. So the answer you see. Okay, so we derived. Similarly, the a cos omega t problem also we derived. So for a cos omega t, s divided by s squared plus omega squared. Okay, so S by S squared plus omega squared is a problem for cos omega naught t, omega naught t. Okay, similarly, what is the find the Laplace transform of e power minus at cos omega t. So this problem also we calculated, that is in the cos omega t for Laplace transform answer. You just replace S by S plus A, means that is the Laplace transform of e power minus at cos omega t. Okay, so cos omega t answer is S by S square plus omega square. That's why the Laplace transform of e power minus at cos omega t is, you just replace S in the place S plus A. So S plus A by S plus A the whole square plus omega square. Okay, this is the answer. Similarly, the next question you see, find the Laplace transform of sine omega t. Okay, so the Laplace transform of sine omega t is omega divided by s squared plus omega squared. Okay, so in sine omega t, cos omega t, the denominator is same. The numerator is different. In cos omega t, it is a s. In sine omega t, it is a omega. Okay, so omega by s squared plus omega squared. Okay, so you have to remember the standard answers. And similarly, find the Laplace transform of e power minus at sine omega t. So in the sine omega t equation, if you are replacing s by s plus a, means we will get the answer. So that's why the answer is omega by s plus a the whole square plus omega squared. This is the answer. Okay, so these are all the some of the standard signals. Okay. So you see, I will explain. This is the Laplace transform of some standard signal. You have to remember it. Okay, with the ROC values. So del of t, impulse signal, the Laplace transform is 1. ROC is entire S plane. Okay, so using this, you may receive 2 questions. And U of t, unit step signal, the Laplace transform is 1 by S. And the ROC is sigma greater than 0. That is, sigma means real part of S. Okay, sigma greater than 0. And the third one, R of t, ramp signal. The ramp signal is having the Laplace transform value is that 1 divided by S squared. Okay, 1 by S squared. U of t means 1 by S. R of t means 1 by S squared. With the same ROC, sigma greater than 0. Okay, then e power at u of t, exponentially rising signal, means 1 divided by S minus A. So here e power A means S minus A. With the ROC, sigma greater than A. Okay, so if any signal multiplied with u of t, means it's a causal signal. So for causal signal, always the ROC value, it should be greater than some value, greater than that pole value. Okay, so e power minus at u of t. So the answer is 1 by S plus A. If it is a minus here, means here plus. Here plus means minus. Okay, that is the thing. So 1 by S plus A. With the ROC value, sigma greater than, what is the pole here? Okay, the pole value is S equal to minus A. So sigma greater than minus A is the ROC value. Okay, similarly, minus e power minus at u of minus t. This is the anti-causal signal. Okay, so this signal is available for the negative duration of time. This signal is also having the same Laplace transform answer 1 by S plus A as that of the previous sum. E power minus at u of t and minus e power minus at u of minus t is having the same Laplace transform answer. But the ROC, it will be different. Since this signal is a causal signal, that's why the ROC is greater than minus A. This signal is an anti-causal signal, that's why the ROC value sigma, it should be less than minus A. Okay, so this is also one of the question, which two signal is having the Laplace transform, same Laplace transform value, but it will differ in ROC, means this is the answer. Okay, so you have to remember it. Similarly, e power minus at u of t minus e power at u of minus t. Okay, so combined signal is the one. Then A sine omega t. So you know the omega t answer is omega by S square plus omega square. If it is having the amplitude A, means you put the constant A. And ROC for sine signal is sigma greater than 0. Similarly, cos omega t, S divided by S square plus omega squared, with the ROC is same, sigma greater than 0. Okay. Then e power minus at sine omega t means in the sine omega t value, you just replace S by S plus A. Okay, this one. Similarly, e power minus at cos omega t means in the cos omega t answer, you just replace s by s plus a. Okay. Then one more thing, t power n e power at u of t. So one ramp function multiplied with one exponential signal. Okay. So this thing, it will have the answer is that n factorial by s minus a to the power n plus 1. That is, e power at u of t answer, 1 by s minus a. If e power at u of t multiplied with t power n means the answer is additionally n factorial by the s minus a to the power n plus 1. Okay, this is also one of the standard signal. So these are all the some of the standard Laplace transform signals. You have to remember it. So using this, so many questions it will come. Okay. So we discussed. Then the next part is from the thing that is properties of Laplace transform. Some questions. Okay. So first you see, as per the time displacement theorem in Laplace transformation, displacement in the time domain by t becomes, okay, so what's the meaning? If you are displacing the signal x of t, the original signal x of t by some time capital T means, so what is the transformation happened in Laplace transform? That is the question. So x of, as per the time shifting property of Laplace transform, x of t minus capital T, the Laplace transform answer is that the Laplace transform of x of t multiplied with e power minus s into t. Okay, so you see the four choices. One is division by s in s domain, division by e power minus st in s domain, multiplication by s in s domain, multiplication by e power st in s domain. So here multiplication by e power minus st in s domain. This is the answer. So if you are taking Laplace transform for the time shifted signal means the answer is that the x of s is multiplied by e power minus s into that shifted value t. Okay, this is the one. And next question, if x of t, the Laplace transform is x of s means, then what is the Laplace transform of x of at? What is x of at? It's a time scaled signal. Okay, so if you want to find the Laplace transform of time scaled signal means we have to use the property, time scaling property. So as per the time scaling property, x of at signal is having the Laplace transform is that 1 divided by modulus a x of s divided by a. Okay, this is the time scaling property. Okay, so using this, which one is correct? So x of at 1 by a, x of s by a. Okay, this is the correct choice. So the remaining things are a little bit error is that. Okay, so what is the Laplace transform of x of t into e power s naught t? So this is the property shifting in that is scaling in s domain. So as per the scaling in s domain, any signal x of t multiplied with e power s naught into t means the Laplace transform of this product is that Laplace transform answer x of s shifted by s naught amount. Okay, this is the scaling in s domain property. So according to this shifting in s domain, okay, this is the shifting in s domain. As per this shifting in s domain property, we will get, so which one is correct? X of t e power s naught t. It gives the answer is that x of s minus s naught. Similarly, if x of t multiplied with e power minus s naught t means the answer is x of s plus s naught. Okay, so that the thing is shifted to left side. Then the Laplace transform of x of t is x of s. Then what will be the Laplace transform of dx of t divided by dt? That is a differentiation of the particular signal. So as per the differentiation property, so this differentiation property, it plays a very important role in the analysis of system. Okay. So as per the differentiation property of Laplace transform, the answer is that s into x of s. Okay. So we discussed this question in Fourier transform also. So the Fourier transform of a differentiated signal is j omega into x of j omega. Similarly, the Laplace transform answer is that s into x of s. Okay. So this is the differentiation property. dx of t divided by dt, the Laplace transform is that s into x of s. If it is a Fourier transform, j omega into x of j omega. Okay. Then In Laplace transform, the multiplication by e power minus at in time domain becomes translation by a in s domain, translation by minus a in s domain, translation by e power minus as in s domain, none of the above. So a translation by a in s domain. Okay, so this is the property that is e power, this one, any signal multiplied with e power s naught t means the answer is that x of s minus s naught. Similarly, in the place of s naught, if it is a, okay, so a is available, minus a is available means, so the translation by a in the s domain. Okay, then the next one, the Laplace transform of a pulse function of magnitude e and duration from t equal to 0 to t equal to as. Okay, that is the question is we have to find the Laplace transform of one pulse of amplitude e and the duration is from t equal to 0 to t equal to a. Okay, so using the Laplace transform formula. So already you know the Laplace transform formula. What is the formula? Integration minus infinity to infinity x of t e power minus st into dt. So here what is the x of t? The x of t is having constant e over the interval 0 to a. So the integration 0 to a e power minus at st dt. So if you are integrating and substituting the thing, we will get the answer this one, e into 1 by s minus 1 by s into e power as. Okay, then find the initial value of f of t if the f of s equal to s divided by s plus a the whole squared plus s squared. Okay, so we want to find the initial value of this signal. So already you know the property. So in Laplace transform, so there are several properties are there. Okay, that is one is similar to Fourier transform, linearity property, time shifting property, shifting in S domain, time scaling property, differentiation property. Okay, then integration property, convolution property. Okay, then integration in time domain, integration in S domain. Okay, then initial value theorem and final value theorem. So according to the initial, that is what is the use of this initial value theorem and final value theorem. So we solved some problems in the videos also. Okay, that is according to this initial value theorem, the initial value of the given signal is calculated in terms of the Laplace transform. That is the initial value x of 0 is calculated by multiplying s with x of s with the limit s tends to infinity. So in the product s into x of s, we have to substitute s equal to infinity means that is the answer for the initial value. Similarly, the final value theorem, the final value of the time domain signal x of infinity is calculated by using the theorem is that limit s tends to 0 s into x of s. So these are all the initial and final value theorem. So using this we can calculate. So the initial value, so here f of s is given. So small f of 0 is calculated by limit s tends to infinity s into f of s. So s into what is the f of s? S divided by s plus a the squared plus omega squared. So here, here this numerator s into s squared is there. So from the denominator, you have to take s squared as a common. So we can write then that s squared and numerator s squared cancelled. So we will get 1 by 1 plus a by s the whole squared plus omega by s the whole squared. Okay, now you substitute s equal to infinity. So here in denominator, if you are putting infinity, any number divided by infinity is 0. So 1 plus 0, 1. Here it's a 0. So the answer is 1. So the initial value of this thing is 1. Okay, so the answer is, this is a D. Okay, it's not a C. The answer C, a D. Okay, 1 is the answer. Then if the x of s equal to 5 divided by s plus 250 divided by s plus 100 means then the initial value of x of t is. Okay, so similar to previous problem, we can solve. So you see, as per the initial value theorem. Okay, so as per the initial value theorem, sorry, the final value, it's not a final value, it's the initial value theorem, the initial value is calculated by, okay, uh, sorry, so answer is, okay, the theorem I displays, this is the initial value theorem. So as per initial value theorem, the limit t tends to 0, x of t is calculated by limit s tends to infinity, s into x of s. Okay, so here t tends to 0, s tends to infinity. So the x of 0 is calculated by limit s tends to infinity, s into x of s. So s into what is the given x of s? 5 by s plus 250, s plus this. So here this s cancel. Okay, then if you are putting s tends to infinity in both numerator and denominator, means the answer is infinity divided by infinity. So that's why you take from the numerator you take s common, from denominator you take s common, s divided. Then after that you just substitute s equal to infinity. So now here we are substituting infinity here, means 250 divided by infinity is 0. So 0 plus 1, 1. Similarly, 100 by infinity is 0. 0 plus 1, 1. So 5 into 1. So the answer is 5. Okay, this is the initial. So 5 amps is the initial value. Okay, similarly, for the same problem, the final value we have to calculate. So as per, so here we have to use the final value theorem. Okay, so here that is the typographical mistake. So the final value is calculated by, so final value means limit t tends to infinity, s tends to 0. So the final value, as per the final value theorem, the final value is calculated by limit t tends to infinity x of t equal to limit s tends to 0, s into x of s. Okay, so x of infinity is calculated by limit s tends to 0, s into x of s. So you just substitute x of s here. So by in this case, so here this s cancel. Now in the remaining s you just substitute 0. So if you are substituting 0, 5 into 250 divided by 100. Okay, so the answer is 12.5. So the 12.5 is the final value. Okay, so if you want to calculate initial value, you may use initial value theorem. If you want to calculate final value, you may use final value theorem. Okay, then the inverse Laplace transform of x of s equal to 2s plus 5 divided by s squared plus 5s plus 6 is. Okay, so the inverse Laplace transform. So already we discussed inverse Laplace transform in partial fraction method. Okay, so many problems solved in the previous that is videos. Okay, so I will give link for those videos. Okay, if you want to learn, you go and search. So already you know the procedure. In order to find the inverse Laplace transform, first we have to factorize this denominator polynomial. Okay, so s squared plus 5s plus 6, it can be factorized as s plus 3, s plus 2. Then in partial fraction method, this s plus 3, s plus 2, we have to factorize as a by s plus 3 plus b by s plus 2. We have to find out the value of a and b. So here the value of a and b is 1. Okay, then we have to take inverse Laplace transform for this thing. Okay, so if you are taking inverse Laplace transform for this 1 by s plus 2, so according to the standard Laplace transform pair, e power minus 8t u of t is having the Laplace transform answer is 1 by s plus a. So according to that one, the first signal is having the inverse Laplace transform answer is e power minus 2t u of t. Similarly, this one is having e power minus 3t u of t. So the answer is this one. Okay, B is the correct answer. E power minus 2t plus e power minus 3t. Okay, this is the inverse Laplace transform. If f of s equal to 2s plus 3 by s plus 1 s plus 2, the terms in f of t will have, okay, that is the inverse Laplace transform f of t will have what are the terms. Okay, so s plus 1 means, so here if you are in partial fraction method, if you are writing this f of s means a by s plus 1 plus b by s plus 2. So for any value of a and b, if you are taking inverse Laplace transform for some constant by 1 plus s plus 1 means e power minus t. For this e power minus 2t. So that's why the term f of t will have e power minus t term and e power minus 2t term. Okay, this is the one. Next, that is using the properties of ROC. We will have some questions. First one, if x of t is a right-sided signal, then ROC will be dash. Okay, so already you know right-sided signal means the positive causal signal. So the ROC is always greater than some value, greater than some sigma naught. Real of s, it should be greater than sigma naught. Okay, for example, you see u of t. For u of t problem, what is the ROC? Sigma greater than 0. Since u of t is a right-sided signal. And similarly, r of t. For r of t problem also, sigma greater than 0. E power minus at u of t. Right-sided sequence. Okay, so that is the ROC value, sigma greater than minus a. Similarly, if x of t is a left-sided signal means, then the ROC will be real of s less than some value sigma naught. Okay, left-sided means some u of minus t signal means the ROC will be less than some value. Okay, anti-causal signal. For a system to be causal, all poles of its transfer function must be right half of the S-plane. It's a true or false? It's a true. Okay, so for one system, the system to be a causal system, all poles of the its transfer function h of s, it should be right half of the S-plane. Okay, all poles located in the right half of the S-plane means that system is said to be causal. Similarly, a system is said to be stable when all poles of its transfer function lay on the left half of the S-plane. True. Okay. If all poles are lying in the left half of the S-plane means the system is said to be stable. Okay. If the system is said to be marginally stable means one of the pole lies on the y-axis. Okay. So this imaginary axis. If imaginary axis any one of the pole is lying means that system is a marginally stable. If all poles are lying the left half means it is a stable. Okay. These are all the some of the things about ROC. Then what is the Laplace transform of x1 of t convolution with x2 of t? So as per the convolution theorem, so already you know if you are taking convolution in time domain means it gets transformed into multiplication of the individual Laplace transform domain, capital X1 of s into X2 of s. Okay, this is the thing. And find the Laplace transform of del of t minus 2. Okay, so how to calculate this one? Using the time shifting property of Laplace transform, we have to solve this problem. Okay, so the del of t signal. So you know the del of t signal is having the Laplace transform answer is 1. Okay, the answer is 1. So del of t minus 2, if you want to solve del of t minus 2, we have to use the property time shifting property. So according to the time shifting property, x of t minus t naught, the Laplace transform answer is that x of s multiplied with e power minus s into that t naught. So del of t minus 2, the Laplace transform is 1 multiplied with e power minus s into how much time delay? 2. So e power minus 2s. So e power minus 2s is the answer. Okay. Then find the Laplace transform of u of t minus 2. So this problem also we can solve using the time shifting property. So as per the time shifting property, already you know the property. So u of t. So the u of t signal is having the Laplace transform as 1 by s. So u of t minus 2, the Laplace transform is 1 by s multiplied with e power minus s into amount of shift 2. So e power minus 2s by s. So this is the answer. Okay. Then which two signal is having the Laplace transform answer as x of s equal to 1 by s plus a. Okay, so already I discussed in that table. Okay, so which two signal is having the same Laplace transform answer? So you see 1 by s plus a, 1 by s plus a, e power minus a t u of t minus e power minus a t u of minus t. Okay, so the two signals are differed in ROC only. So e power minus a t u of t, e power minus a t u of minus t. This is the correct one. Okay, e power minus a t u of t and minus e power minus a t u of minus t. Then find the Laplace transform of minus e power minus a t u of minus t. So already you know the answer 1 by s plus a. But the ROC is less than less than minus a. This is the answer. Okay, 1 by s plus a. ROC is real of s. It should be, okay, as per this table, real of s, that is sigma, it should be less than minus a. Okay, this is the answer. And what is the Laplace transform of unit ramp signal? So already you know the Laplace transform of the unit ramp signal R of t is 1 divided by s squared. Okay, so already we solved that is the Laplace transform of ramp signal. Okay, we defined using the UDV procedure. We solved the answer is 1 by s squared. And ROC is real of s sigma greater than 0. So sigma greater than 0 is a ROC. So 1 by s squared. This is the answer. Okay, so these are all the some of the questions in the Laplace transform. Okay, so in Laplace transform, you just remember that for a standard signal, all answers you have to remember, and ROC also you have to remember. Okay, sometimes they may ask ROC, what is the ROC of unit impulse signal? Entire explain. What is the ROC of u of t? Sigma greater than 0. What is the ROC of sine omega t, cos omega t? Sigma greater than 0. Okay, then what is the Laplace transform answer for these things? Okay, these are all the questions. And from Laplace transform property, using property also we will get some questions. Okay, so these are all the some of the questions we discussed from the Laplace transform. Okay, so in the next video, we'll discuss about the third unit questions, that is analysis of continuous time system questions. Okay, so thanks for watching my channel, and please subscribe my channel for more videos and keep watching and share this video to your friends also. Thank you.